Good morning, students. Today I am going to start second chapter from physics, that is force and laws of motion. Okay, so in this chapter we will learn about force and Newton's laws of motion. Okay, so first we learn about what is force. Generally, if I want to open this pen cap, we have to apply some force or not? Yes. If I want to stretch this band, see, we are applying some force or not? Yes. If I want to open this box, I have to apply some force. Or if I want to lift this paper or book, I have to apply some force. Isn't it or not? So, in short, we can write the definition of force is a push or pull on a body is called force. What is force? A push or pull on a body. When we are opening, when we want to open the door, okay, sometimes means either we have to push, isn't it, or not? Whether we have to push that side or we have to pull our side. That is nothing but a push or pull on any object. On any object, either if we are pushing or if we are pulling, nothing but that one we will call it as force. Whatever we are pushing or whatever we are pulling on that particular object, that push or pull only we will simply call it as force. Clear? So here, when so many examples we can tell. Force will be used when only I said when we are stretching a rubber band we will use force. When we have to lift a box from the floor we have to use the force, and when we fly a kite we actually feel the force of the wind on it. Okay, so like that, whenever some work or something we have to lift or something we have to stretch means we have to apply the force. But force we cannot see directly. Okay, force we cannot see the force directly, but we can see the effects of force. What we can see? We can see the effects of force. Actually, there are 5 effects are there. Remember, we cannot see the force, but we can feel the effects of the force. If we will see the first effect of the force, that is a force can move a stationary object. What a force can do? It can move a stationary object. If something, for example, this is in stationary position, if I will apply force, it will move or not? Or if it will move by itself? No. If I will apply some force, then only it will move. Isn't it or not? So a force can move a stationary object. If we are applying any force, we can able to move the stationary object. Okay. Second one, a force can stop a moving object. A force can stop a moving object. For example, in cricket we will see when the ball is coming, the bowler will go and stop the ball or not. So by applying some force only he is able to move that moving ball. Isn't it or not? So by applying force we can able to stop a moving object. Clear? And third one is a force can change. A force can change the speed of a moving object. The force can change the speed of a moving object. Here also cricket only we can take it as example. When the bowler will bowl the ball in with some speed. When the batsman hit that ball, definitely the speed of the object will change or not? Or okay, for example, if you are going to school, okay, so maybe you are getting late to school. So by applying more force, you can increase the speed of your cycle or not? Isn't it? Or if you want to decrease the speed means if you are applying less force means automatically the speed will decrease or not? So by applying force, either we can increase the speed of moving object or we can decrease the speed of a moving object. Then fourth one is even a force can change the direction. A force can change the direction of moving body. If this one also cricket, when the bowler is bowling from back side, The batsman will hit from opposite side or not. So by applying force only, the ball is coming in this way. Okay, here the batsman will apply force, so immediately the direction of the ball is changing or not. On what process it is depending? Because of applying force only, na, the direction of that ball is changing. So the force can change the direction of a moving object, and even a force can change the shape of a body. This is of shape of the body means like when we are making that duff we are that what I will say, puri roti we are making that duff. So when we are making that one, we can change by applying force, we can change different shapes or not, isn't it or not? Even by when we are taking elastic rubber bands, by applying force only we can change the shape of a body or not. So even by applying force, in some cases even we can change the shape of a body. Clear here? So these are the effects of the force. We cannot see the force, but we can see the effects of force. Clear here, children? So next one is balanced and unbalanced forces. Okay, balanced and unbalanced forces. So here forces are of two types. How many types? Balanced forces and unbalanced forces. First we will learn what is the balanced force. See, the definition of balanced force is if the resultant of all the forces, acting on a body is 0, the forces are said to be, the forces are called balanced forces. Okay, what do you mean by balanced forces? If we will take any object, okay, one body we are taking, okay, so here the forces whatever acting on this object, if all the forces are equal and become 0, okay, then the resultant, whatever resultant will be there na, that one will be, that means if the resultant of the all the forces acting on the body is 0, means see here, for example, I am pushing this box from this side. Okay, here I am pushing this box from this side. Here maybe this is force of our push. Okay, force of our push. Here opposite side there will be one type of opposing force, that is frictional force. Okay, always means if they both are equal. Okay, we are applying some force, but though we are applying some force, this box is not moving, means this frictional force is opposing the movement of this box. Okay, whatever force we are applying here is not enough to move this box. Okay, so this frictional force and our force will be equal with each other, and there will be no force acting on here. Even from downside, we know gravitational force will be there. Okay, gravitational force like this arrow mark, gravitational force, and upwards this weight of the box will act upwards. So this weight of the box and gravitational force, nothing but they both will be equalized, and here they both will be get equalized and get cancels, and here also they both will be equalized and get cancelled. So finally the force whatever is acting on this object is 0. See, the resultant of all the forces, this both are equal, this both are equal. Plus 2 minus 2 how much? 0. Plus 5 minus 5 how much? 0. So here also these forces are equal, so the resultant will be 0. These forces will be equalized, so the resultant will be 0. Means like that, if any object is there, okay, so that type of forces means if like that forces are acting on any object, means that type of forces we will call it as balanced forces. Okay, then what do you mean by unbalanced? Same, if the resultant of all the forces acting on a body is not 0. Okay, what is that? If the resultant of all the forces acting on a body is not 0, means then those type of forces are called as unbalanced forces. That type of forces are called as unbalanced forces. For example, take one toy car. Okay, I have taken one toy car here. So here I am applying some force here. When we are applying some force on some small toy car, automatically it will move this side or not, isn't it? Why? Because here this is the small one. Whatever frictional force will be there, means even though we are applying small force, it can able to move here. It will overcome this frictional force and it will move, isn't it or not? Whereas these two forces will be equalized, whereas but these two forces will not be equalized. Here whatever force applying by us will be more here, so automatically the car will move. So here these two are not equal, na? These two forces are not equal, so automatically the resultant force will not be zero, isn't it or not? So here if the resultant of all the force is not zero, means something is moving here. These both are not equal. Here it is more than this frictional force, isn't it? Our force is more than this frictional force. So here the force is not zero. So this type of forces we will call it as unbalanced forces. Clear here, children? So these are some of the two types of forces, that is balanced and unbalanced forces. So generally whatever we are considering in our chapter, force means that is related that indicates unbalanced force only. Why? Because in order to always means instead of using always unbalanced force, simply we will mention it unbalanced force as force in this chapter. See here in your textbook so many examples has been given about balanced and unbalanced forces, so that if you go through now you will get more idea about the balanced and unbalanced forces. Clear, children? So afterwards I am going to Newton's laws of motion. Today I will explain about only first law. Okay, so Newton's laws of motion. Clear, children? First law today we are going to learn. This Newton was the scientist given 3 laws to describe the motion of body. Okay, how many laws he has given? He has given 3 laws to describe the laws of motion. Clear? So here we will see now some of the body around us are rest. Isn't it or not? Some of the bodies around us will be at rest position. Some will be in moving position. Isn't it or not? So Newton's first law tells us the behavior of such bodies. The behavior of such bodies means the bodies which are in rest and also the bodies which are in uniform motion in a straight line. Okay, so today we will learn about Newton's first law about 2 type of bodies, that is the bodies which are in rest and the bodies which are moving in uniform motion in a straight line. Clear? So now I am telling what is the exact definition of Newton's first law. See here, children, carefully. A body at rest will remain at rest. A body at rest will remain at rest, and a body in motion will continue in motion in a straight line with a uniform speed unless it is compelled by an external force to change its state of rest or of uniform motion. See, children, this is the exact definition of Newton's first law. So let us see the meaning of this law. A body at rest. will remain at rest. Means if your body is there means, if your body at rest means it will be always in rest position. And a body in motion will continue in motion in straight line with a uniform speed. Or if some body is moving, it will be always continue in motion in a straight line. Means for example, if one body is moving in a straight line with uniform speed, that body always it will be in motion. And here one condition is given: unless it is compelled by an external force to change its state of rest or of uniform motion. Means if there is any external force acts on these objects, means for example one object is rest. Okay, if any external force only acting on this one, then only it will change its state of rest position. That is the Newton's first law. What is telling? A body at rest will remain at rest. If your body is there in rest means always it will be in rest only. Up to when? Unless it is compelled by an external force. If some external force is acting on it to change its rest position, up to then it will be in rest position only. If some force is acting on it, then only it will change its rest position to motion. And second one also, a body in motion, if some bodies go on moving in a straight line with uniform speed, okay, it will go on like that. Up to when? Unless it is compelled by an external force to change its state of uniform motion. Means if some external force is acting on it, then only this moving object will comes to rest. This is Newton's first law. What is Newton's first law? If your body at rest means it will be always in rest. Up to when? Unless it is compelled by an external force. Means some force is, for example, this pen only is there. Okay, this pen will be in rest position only, always. Up to when? Means if I apply some force here, if I apply some force to change its position, then only it will change its position. Isn't it or not? If I am not applying any force, no external force is acting on the body, means that pen will be in rest position forever. Isn't it or not? So that is Newton's. Or second one is, if an object is moving like this. Okay, one object is moving like this means it will what given? A body in motion will continue in motion in straight line with, means if any body is moving in a straight line, that too with uniform speed. See here, with uniform speed, if any object is moving in straight line, it will be continue forever. Okay, up to when? Unless it is, if some external force is coming and stopping that object, then only it will come to rest. That is Newton's first law. Clear, children? Here, related to Newton's first law, one more thing you have to learn, that is inertia. What is that? Inertia. So here, inertia means, see here I am writing the definition. The tendency of a body to remain at rest. The tendency of a body to remain at rest, or if moving, to continue moving in a straight line is called inertia. See here, related to Newton's first law, one more topic you have to learn, that is inertia. What is inertia actually? Okay, inertia is nothing but some tendency of a body, means like a desire, want. Okay, so the tendency of a body to remain at rest. For example, this body is in rest. Okay, this body always wants to be in rest only. Okay, if we will apply some external force only, it will move, isn't it or not? So that if any object is in rest means it always wants to be in rest only. Or if something is moving in a straight line, always it wants to move only. So here inertia means the tendency of a body to remain at rest, or if moving, to continue moving in a straight line is called inertia. Okay, this inertia always relates to the mass of that object. Mass of that object. If the object is having more mass, it will be having more inertia. If it is having less mass, it will be having less inertia. For example, I have taken some 20 kg stone and 2 kg stone. Okay, if I will apply small force here, it will able to move or not? Isn't it or not? Why? Because it is having 2 kg means less mass. Less mass means less inertia. Even though it is having tendency to be in rest, but whatever force I am applying, maybe it is more than enough to move it. Okay, so here if we will apply same force on this 20 kg one, here it will not move. Why? Because the tendency of this object is high. Why? Because it's in rest means always it wants to be in rest only. Okay, if I want to move, this means I have to apply more force. How much force means I have to overcome this inertia. How much it's having inertia, na? The tendency to be in rest. So I have to apply more force, then only I can able to move this heavy mass. Clear? So here the tendency of your body to remain at rest, or if moving, to continue moving in a straight line is called inertia. Okay, so here inertia is that property of your body due to which it resists a change. Due to which it resists a change in its state of rest or of uniform motion. Clear, children? So this example, this not example, this one we have to, inertia is Newton's first law. In this Newton's first law, this inertia you have to learn. Okay, if in here so many examples also given in your textbook with a cricket ball and rubber ball. If you say if you want to move a cricket ball or rubber ball, so cricket ball will have more inertia, so more force you have to apply, isn't it or not? So like that. And if we will say, see so many examples here given. For example, this okay. Here first word, which one we have? First one, obviously first, a body at rest will remain at rest and a body in motion will continue in motion. A body at rest we have discussed. For example, this is at rest. This stone is at rest now. When okay, I have to, this pen one only I told now. This pen is at rest. If I will apply some force means then only it will be moving, isn't it or not? This is first line you will understand. A body at rest will remain at rest unless it is compelled by an external. So to understand the second one, a body in motion will continue in motion in a straight line. This one we will see the examples to confirm that one. See here, when you are throwing a ball or something, okay. For example, you are moving if you are pedaling a bicycle, okay, if you are pedaling a bicycle and suddenly you stopped that pedaling that bicycle, okay, and remember that you are moving in a uniform speed in a straight line, okay. You remember that you are moving with uniform speed in a straight line. After some time you stopped that pedaling that bicycle, okay. So the bicycle does not go on moving forever, isn't it or not? Even though you you stopped pedaling, but after some time it is coming to rest or not? How it is coming to rest? Here it comes to rest. The moving bicycle has been compelled to change its state of uniform motion by the external force of air resistance. By the external force of air resistance means if you are even though you are means you are not pedaling, means after some time it will come to the rest position. Why it is coming to the rest position? Because of the air resistance. If there is no air resistance, okay, if there is no air resistance and there is no friction to oppose the motion of a bicycle on the ground now, then it would be continue forever. A moving bicycle would go on moving forever. But why it is coming to rest means because of air resistance and frictional force acting between ground and the cycle. Okay.